In the wires, we're the ghost. Ego's king, we rule the host. Masks on screens, we wear them proud. Silent hands inside the cloud. Flicker in the firewall glow. Name in red on a watch list row. Every trace that they think they own, we erase, turn it all to smoke. Hack the world, that's the dream. Pull the thread of the global scene. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the crack machine. Hack the world, the final scheme. Reach the system, break the code. Watch the virus overload. Black hood up, eyes run cold. Turn the silver into mold. 10 fake memes on a single wire. One small spark, whole grid on fire. Who owns what when the locks all fail? Who holds power when we lift the veil? Heartbeat sync with the scroll. Cursor dancing on the soul. All their walls built tall and proud. We just walk straight through the crowd. Hack the world, that's the dream. Pull the thread of the global scene. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the crack machine. Hack the world, the final scheme. Are you in or out tonight? Ride the edge or run from sight. When the curtain tears in two, will the ghost look back at you? Hack the world, that's the dream. Pull the thread of the global scene. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the crack machine. Hack the world, the final scheme.
No. Okay. There are two voices coming. Let me check why. Hello, hello, hello. Is there two voices coming still? Bro, I have this one.
I'm trying to connect.
Okay. That speaker is off. Bro, I changed my phone after 7 years too. Don't worry. This speaker I got from like a giveaway. I didn't even pay for it. Is there, are you, is the voice correct? Are you getting two voices or what? I feel like somewhere. Yeah, I also got it like around 17, 18. बिकॉज मेरे को आ रही है इसलिए ऐसे फील आई थी. चल कोई ना, मेरे को एक सेकंड देना, मैं अपनी है ना थोड़ी मेरे सर दर्द था तो मैं उसकी दवाई लेके आ रहा हूँ. भाई मेरा हल्का सर दर्द था तो मैं उसकी दवाई लेके आ रहा हूँ. उसके बाद स्टार्ट करते हैं स्ट्रीम प्रॉपरली. या उसके बाद पता है क्या करेंगे? सुन, we are going to cover majority or try to cover as much as possible about the whole CCP exam. No, not drugs, just a simple like basically paracetamol, right? If I in simplest words. So, but what we'll do, we'll cover. I will try to cover as much as possible because I just got coffee. I was like, this AWS has been carried like a lot because of my work. I have like just kept taking more and more time, right? So I will try still to complete all the information this week, which means today and tomorrow. And today is a good day. We should be able to cover a good amount of stuff, right? I have the energy. I just need my medicine so my head doesn't hurt, and I will be back. I'll play the song till then, so you guys enjoy that, and I will be back in just 1 sec.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44.
Audio coming, which is amazing, or ad coming. Okay, I don't want you guys to go through that.
Shape.
Okay, please, I will be back in 1 sec.
In the wires, we're the ghost. Ego's king, we rule the host. Masks on screens, we wear them proud. Silent hands inside the cloud. Flicker in the firewall glow. Name in red on a watch list road. Every trace that they think they own, we erase, turn it all to smoke. Hack the world, that's the dream. Pull the thread of the global seam. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the cracked machine. Hack the world, the final scheme. Wish the system, break the code. Watch the virus overload. Black hood up, eyes run cold. Turn the silver into mold. 10 fake memes on a single wire. One small spark hole grid.
Okie dokie do. Alrighty, I'm ready. Let's get started with AWS Cloud Practitioner Essentials. 12 hours and 45 minutes course. Going to cover introduction to cloud, compute in cloud, exploring cloud services, going global, networking, storage, databases. Storage and databases are different. Remember, AI, machine learning, and data analysis, security, monitoring, compliance, and governance in AWS cloud. Pricing support is easy. Migration is easy. Well architectured solutions are easy. Okay. So let's get started. Here is the module link. It's a free ID you can make. It's a free ID you can make. So just do make it. Make sure you do that, right? Have you guys done that? Like, have you done created the account or no? Hopefully you did. Okay. Next is being let's get started with this. Basically, description, and I'm going to share all the notes I'm making. I will be sharing it online through my what's it called, GitHub Hacker Notes. That's the name on GitHub, syncing to GitHub remote, right? So this is just the description outline. What basically the whole idea of CCP course is to show that you know about AWS and all its services to your employer or to anyone, that hey, you know the basics of cloud. What is cloud? What are storages, concepts, databases, governance, cloud computing? Just a very simple course, but a good to build foundation so that we can go to like solutions architect, machine learning associate, and all those AI learner, AI practitioner, those ones. Okay. So we'll cover with this. So module 1, introduction to cloud. Let's start this module. How to use each module, right? Course navigation. The following are 4 essential tips for navigating through this. So first one, searching content. We can search for various content here. Beautiful. Navigating to previous one. So if we click on the previous one here, we can click on the lesson which we want to go through, and we can go to the next lesson one at the bottom. Really well done. I will say I like this simple style. Welcome to AWS Cloud Practitioner Essentials. Also, just letting you know, I have purchased went to certain places, purchased certain questions for AWS one. So that will also be there on the GitHub. So welcome to AWS Cloud Practitioner Essentials. Welcome to AWS Cloud Practitioner Essentials. It is the initial section of training. You begin with the foundational understanding of cloud computing and how the cloud revolutionizes the way business operates. No, it's fine. By the end of this first set of lessons, you will be familiar with the core concepts, benefits, and shared responsibilities of cloud computing. In this lesson, you will learn how to do the following. Describe the client-server model at fundamental level, right? What is client-server model? In basic terms, right? In very, very basic terms, when we are talking about cloud, right, we have two things simply. Two are very fundamental things. One is you and how you are interacting with anything. That's through your browser. Here, 1 second. Yeah, that should do the job. Yeah. So one is your browser. Your browser is also called client. System की पूरी book. Nice, bro. That's good. Yeah. Next, so what we were talking about was browser client, and second is the server. So that's basically how the cloud works. You, through your browser, are able to interact with services on AWS servers, right? So here we have AWS servers, right? We are able to create like things like virtual machines, databases, load balancers, stuff like that through a simple client server architecture, right? So describe the client server model at fundamental level. In the following video, you will meet your instructor and learn learn about some fundamental cloud principles, right? So let's watch this guy.
Hey everyone, welcome to the course. We hope you're ready to dive in and learn the fundamentals of the AWS cloud.
We have a lot of material to cover, and we're going to start with defining what is the cloud.
But before we do that, let's start with some introductions. Hi, I'm Morgan Willis, a principal cloud technologist with AWS Training and Certification. I started in the IT world about 15 years ago, and along the way, I decided that I was missing something. I missed the helping and teaching aspect that I had in my first job in IT support. So I went into teaching at a software development bootcamp, and then I eventually landed here at Amazon Web Services, or AWS, where as a cloud technologist, I get to support others in their cloud learning journey every day.
How's it, learners? My name is Rudy Chetty, and I'm a Chief Techfluencer and a Principal Solutions Architect for AWS Partners. I'm originally from sunny Cape Town, South Africa, the home of Bunny Chow, Biltong, and Boerewors. I've been in the technology space for over 2 decades, helping customers worldwide realize their application
That's true.
and cloud dream. Education is my passion. Therefore, I cannot wait for you to dive into this course and learn all about the wonders of the cloud and AWS.
And I'm Alan Meridian. I'm an instructor in AWS training and certification. Over the last 8+ years with AWS, I've delivered hundreds of trainings, introducing learners like you to AWS concepts, services, and solutions, sometimes involving ukuleles. I'm glad you're here. We're going to learn a lot together.
Look, Cloud computing can be complex, but don't worry, this is why we're here. Our curriculum provides analogies, examples, and use cases that will help you better understand these concepts. We'll cover all the essential information you need to be comfortable discussing AWS. Additionally, we'll throw in some AWS service demos to show you how things work in action. This layered approach to learning will really reinforce concepts. Oh, and we promise to keep it simple.
I don't have many words, right? Because I think everybody understand what they are saying, what they are doing. Basically, they are going to at the end saying we will have hands-on lab. We will have enough information to pass our AWS CCP. And don't pay much attention to this video.
AWS offers a massive range of services for every business. AWS is the world's most comprehensive and broadly adopted cloud, and millions of customers use AWS to be more agile, lower costs, and innovate faster. Whether you're looking for compute power, generative AI, databases, storage, content delivery, or specialized services for some other functionality, AWS has the services you need to help you build sophisticated applications for your business.
That is a massive range of...
Yeah, dude. So we are just covering as much as information about AWS CCP, which is like a course. Remember, we were talking about this. We'll cover this as much as possible. And I have, oh, by the way, code guys, send me your Twitch link. I will share it in my Discord. Second, I have messaged somebody in Hack the Box. We might be able to get some bulk vouchers, and I might be able to do more Hack the Box giveaways, and might even talk to AWS skill builders and see if we can get some vouchers or discounts for this certificates. Okay. Okay. No, we'll focus. Yo, this is 11:20 for me. You guys have to focus with me. I want to cover this in 2 days. Whole thing. I'm ready to go go for like 2, 3, 4 hours. I have my coffee ready. I've been drinking. Let's focus.
Services, and I wish we had time to cover them all, but we did promise to keep it simple. So let's start this conversation with a fundamental concept of computing, the client-server model.
And to get things percolating in your brain, we are going to brew up a coffee shop analogy.
Client-server architecture, we talked about this. Simple. Your browser is client, right? And just like anything on internet, your browser is client and it's talking to some server, whether you're opening Facebook, Google, Amazon Web Services, or Amazon Shopping, or YouTube here, right? There is a server, you are the client, there is a communication going on, right? In case of AWS, you are able to do things like spin up virtual machine, get databases, load balances, stuff like that, right? Yeah. Okay, let's go.
This coffee shop is going to act as a real-world metaphor to show you the different parts of the cloud computing model. And the analogy will help you understand how AWS can change the way your IT operates. First, let's think about the coffee shop and how it can represent the client-server model.
Let's have Morgan be the server, the barista, and I'll be the client or the customer. I'm going to make a request. In this case, it's for coffee. In the computing world, the request could be for anything. It could be rain pattern analysis in South Africa, or it could be the latest x-rays of your knee, or videos of kittens. Whatever the business needs is where the request starts. Basically, a customer makes a request, and with permissions, the server responds to that request. All I want is a caffeinated beverage. Morgan represents the server part of the client-server model. In AWS, she would be a virtual server. So from a cloud computing architectural point of view, the coffee shop transaction is pretty straightforward. I, the user, made a request to Morgan for the server. Morgan validated that the request was legitimate. In this case, did I give her money? Is the item that I ordered something that they can make? Then she returned a response, which in this example is a triple mocha with extra caramel shots.
Now,
to give you guys a better analogy or like some examples. Almivar, what's up, bro? Coffee and bacon indeed. Hell yeah. One of the most deadly combinations out there. So, but what they said, right, was an interesting thing. But it's not always correct, right? Whenever you send a request, right, there is some processing happening for sure. There is some processing happening to understand what's going on, and then if the request is valid, you will get a response, and if the request is not valid, you will still get a response, right? Those are the 404 error. This is not available. 403 error, right? A bunch of other ones, 301 error, depending on what the processing happened and what your request was. So processing happens, and based on the process, you will get the request. Yep, that's true too. 500, all those, right? If it's legit, you will get like a JSON response majority of the time with your APIs. Okay, that's basically it. What you need to understand with the client server model, you send a request, get a response back. Let's go back.
Now, in the real world, applications are usually more complicated than just a single transaction with a single server. In a business solution that is more mature, it can get beautifully complex. But again, we're going to start with the basics. As the curriculum progresses, these basic concepts will continue to build on each other, and hopefully, by the end, those beautifully complex concepts will make a lot more sense. You've already tackled your first cloud computing concept. So now let's continue with a key concept of AWS, and that
I have put the link in Discord. I will just put it here as well. You can buy this. It's free. You don't have to buy this. A skill builder. This is the free one. You can just go and create your free account.
is you only pay for what you use.
Think about this principle as it applies to staffing a coffee shop. Employees are only paid for the hours they work in the actual shop. So if, say, Morgan and I are off the clock, well, then we don't get paid because we didn't work any hours. Moreover, the store owner decides how many baristas they need for any given day of the week. Busy days require more employees and slower days require fewer. Let's take an example. Say the coffee shop is releasing a brand new drink called Rudy's Rhubarb Refresher, trademark. The shop anticipates increased demand due to the beverage being very tasty. So they staff the shop with 10 baristas all day long. Although this works with a sudden surge of customers, it isn't great for slower periods during the day. Some baristas could be idle, and it would be hard to justify paying them to just be there in case they are needed. The monetary cost just doesn't make good financial sense.
Yeah, and yet that is exactly what happens in an on-premises data center where you can't just snap your fingers and triple your capacity. At AWS, you don't prepay for anything, and you don't have to worry about capacity constraints.
When you need more resources, you just provision them right then and there. How cool is that? Then, when you don't need those resources anymore, you can deprovision them just as quickly. You just set up the right configuration and it's done automatically. And the best part is that when you deprovision the resources, you stop paying for them immediately.
What? With these, what's the hassles? What? I didn't get the last one. Can you explain? Sorry, I didn't get the last one. But yeah, so basically what they're saying is, two concepts they have mentioned here, which I want to talk about, which I won't go further in detail, but two concepts they talked about. One is pay as you go. Think about this way, right? You ordered, let's say, a lot of food, right, at a diner. Let's say, or it's like a buffet system, not even buffet, I will say. A good would be like, let's say you ordered a drink, right, at the coffee shop, and the drink is filled up to here, but you only consumed, let's say, 50% of the drink, right? Same you might have seen in your house with the electricity, right? there is like you can consume unlimited amount of, theoretically you can consume unlimited electricity, right? My handwriting. You can consume unlimited electricity, you can consume unlimited water in your house, right? You can get that. But you don't do that. You only consume the electricity or water, the amount of electricity and water you need, and so you only pay for that. Cloud computing have the same freaking concept. You only, right, get billed for the amount you use. Same with cloud computing. Or if you are ordering 2 servers, you only have to pay for those. Yeah. That's what they are trying to say with the baristas. If you want 3 baristas, you only pay for them. But if, let's say, the demand is more, you can go for more. Just like electricity, if you want more, like turning on the microwave or something, then you will pay for that. But once the microwave is turned off, you don't pay for it. That's the whole concept of cloud and why it is so important for, especially for startups or big companies whose demand goes up and down, up and down, up and down.
Just like you only pay your employees for the hours they're working, you only pay for the AWS resources that you consume.
Right. So paying only for what you use is the first AWS specific concept we covered. And it's just one of the many benefits when it comes to running your business on AWS. And that's really why we're here. So you can understand how AWS is built to help you run your business better.
Exactly. You've already learned some foundational concepts about the cloud, and that's just the start.
Yep, things are only going to get more interesting, folks, as we dive deeper. Thanks for joining us on this learning journey, future AWS Cloud Practitioner. See you soon.
I hope they don't have many videos about these, and it's more like reading things. So we have AWS Cloud Practitioner Coffee Shop. In this training, we use coffee shop analogy to help you better understand basic cloud concepts. To explore the coffee shop and learn more about your instructors, choose each of the following 4 markers. So first we have the client coffee shop connections. In this video, we used the example of customer ordering a cup of coffee to explain client server model. We are requesting for Facebook page, we are requesting for a YouTube video, we are requesting for images of something, or like we are requesting like a different page or anything, right? So just like that, in a coffee shop, clients are offering, asking coffee, tea, something, cupcakes, whatever. Do you want me to go over all these? As this training progresses, you will continue to see comparisons between elements of coffee shop and cloud computing functions. For example, you will explore how different AWS compute instances are, kind of like the different types of coffee machines in a coffee shop, right? Each machine is workload specific to better serve its customer. Just like there are different types of coffees, some are espresso, very, very heavy when it comes to caffeine. Some are decaf, not that heavy. Same idea. Servers, some are compute heavy, really important with like GPUs and the best processors. Some don't need that much, right? The purpose of the coffee shop and analogy is to reduce the complexity of cloud concepts, take the cloud knowledge and theoretical concepts, practical stuff, blah, blah, blah. Alan Meridian is the tech lead at AWS. When he is not drawing networking diagrams, Alan is likely playing. Oh, okay, the guy. Okay. Morgan Wells, outside of Morgan, enjoys hiking, blah, blah, blah. Same thing. Rudy, same dude, like basically he has been even in a Pizza Hut, blah, blah, blah. Basics. I don't know why they put this. Test your skills. In a coffee shop example, a barista and customer were used to represent client server model. The barista represents the server and a customer represents the client. Which scenario best describes how the client server model works in the analogy? Please answer it along with me so I know if you are getting it. If not, let me help you explain, right? Let me know. The customer takes and do answer even if you think it's wrong. So I would know. It would be better for even you know if you're wrong. Customer takes a cup of coffee from a self-serve station without informing the barista. This describes how client and server do not interact. The barista proactively prepares a coffee and brings it to the customer without being asked. This describes how the client does not need to submit a request to the server. The customer makes their own coffee using coffee shop equipment without interacting with barista. The coffee customer goes to the barista, places an order, the barista prepares the coffee, hands it back to the customer. Describe how client places the request. Fourth one, anybody else have any other answers? Tick tick one, tick tick two, tick tick three. No, that's fine. Yes, fourth one is correct because honestly, that's how it is. Like all these doesn't make sense. Fourth one, when you go to a customer, you as a customer, you go to a coffee shop, ask the person like, "Hey, this is my order." They prepare your order, you get it back. Done. Simple. And honestly, cloud is very simple once you start doing it, and I'm here to help you with that. What is cloud computing? In this lesson, you will learn about how define cloud computing and differentiate cloud deployment models. Damn, they have videos in every single one. In today's technological world, you are probably familiar with the concept of the cloud, but you might not know the technical details of how cloud computing works. In this lesson, you will learn the basic definition of cloud computing and how you explore how AWS helped pave the path or wave to new technology frontier. Okay, let's get into this.
Before we dive into cloud computing, let's rewind the clock and set some context for how Amazon grew to include Amazon Web Services. In the early 2000s, Amazon.com was an e-commerce site that customers used to buy books and other consumer goods. As more people started to use the site,
I can increase the speed to 1.25.
the Amazon IT team had to continually make upgrades to keep things running smoothly. More servers, more storage, more compute, you name it, they were deploying it. The team eventually decided to develop various standardized tools, mechanisms, and ways to make things more efficient and scalable. These methods proved to be quite effective, and in 2003, employees thought maybe this knowledge would be valuable to other companies facing similar challenges. Thus, Amazon started to envision a service that would allow businesses to rent computing power, storage, and other resources on demand. This business model could eliminate the need for upfront investment in hardware. Just a year later, in November 2004, AWS launched its first public infrastructure service, Amazon Simple Queue Service. 2 years later, AWS launched Amazon Simple Storage Service for data storage and Amazon Elastic Compute Cloud for scalable compute. Initially, AWS was used by smaller startups and developers. However, its scalability, cost effectiveness, and ease of use quickly attracted larger enterprises. Over the next few years, AWS rapidly expanded its offerings by adding databases, networking, analytics, and many other.
AWS does no, it depends. So here's the thing with AWS and the thing you are asking about auto update thing. Depends on which model you have. I'll give a very quick answer to it. There are different service levels, right? There is infrastructure as a service, platform as a service, software as a service. Thing is, it depends on which type of service you are using. Those are the jobs you have to define. So, for example, if your software as a service example being Outlook, you don't care about what Outlook is running behind the doors, whether it's running Ubuntu or is it running Windows. It will automatically be patched. Platform as a service, depending on which one you are, maybe it's like they will auto update it, but you have to work on the configuration ones. Infrastructure as a service, specifically what EC2 you are asking about, I believe I'm very much sure it comes in this EC2 comes in this one, infrastructure as a service, because here You are the one who has to maintain whether what is the software configuration, which license you want, and you have to auto update. All are based on your because you chose infrastructure as a service type service, right? So EC2, no, you don't have to, but depending on which model you choose, you can and you may or may not. Hopefully that answers that, bro.
Other cloud-based services. Fast forward to the present, AWS powers a significant portion of the internet, serving millions of customers worldwide, from small startups and businesses to large corporations, government agencies, and more. What started as an internal solution for Amazon's own IT needs has grown into a global cloud computing leader. With that quick history lesson in mind, let's look at a working definition of cloud computing. Cloud
I won't say Lambda is the best service. Lambda is a great service. Best depends on what is required.
computing is essentially the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Shall we break this down a bit? I think we shall. On-demand means you use resources as needed.
Yet, okay, you ask what is the best, right? What is the best for eating? What is your favorite food to eat? What is your best? What is the food you want to eat 24/7 every day for the rest of your life? Which food? You can't answer that, right? For breakfast, you want something light, maybe heavy, right? For lunchtime, you want something light. For snacks time, you want tea and something. You can't have same food all the time during the day. So the same idea goes with your computing. Yeah, there is nothing like general purpose in that. But that's the thing. You can't have the same thing over and over again, right? I choose tea. Johan, what's up, dude? But what I'm saying at the end of the day, right? You are asking what is the best service. Is same as what is the what you want to eat for breakfast, lunch, dinner, and snack time for the rest of your life. You can't have one answer, right? Same idea here. Depending on what you know, what you need, that will be doing your job, right? For example, if there's a very small function which I can get it done within 1 minute, if I want a program to run after let's say once or twice or three times a day, right? I can just go use Lambda then, right? If there's a trigger or something. But if I want something to run every 5 minutes, I'll go with EC2, depending on what is required. That's why in a what's this called? In a big company, you really need to know majority, at least 50 of the services, or at least 50 services, I will say, out of 200 very well with AWS. And at least I will say 20 should be on your top, on your fingertips. 50 you should be very well versed with, because a company, at least the one I have maintained the infrastructure, I think I will say I have used oof, I have used at least 15-20 services easily. Easily, I can name from top of my head. Yeah. So it just to answer your question, depends what is required. No size fits all type thing. You want to put a nail in the wall, you need a hammer. You want to take it out, it's a different thing. You want a screwdriver. All different cases.
Let's say your business needs 2,000 terabytes of storage. Open an AWS account, throw some files into Amazon S3, and Bob's your uncle. You're good to go. If you don't need to store those files anymore, delete them and stop paying immediately. The idea of the delivery of these on-demand IT resources, as you learned, is the concept that got AWS started in the first place. Let's say you have an application that you have to run, content you need stored, or data you need analyzed. Basically, you have stuff that uses IT resources that have to live and operate somewhere. All of that data is stored in a data center, which is essentially a building or set of buildings devoted to housing servers that contain all this data. Data centers are designed with redundant power, cooling, and security measures to ensure secure and continuous operation.
Redundant For people who don't understand, right, redundant cooling, redundant power basically means that there will be multiple power sources to that building, so that if one power source goes down, just like at your home, just electricity is coming from just one, let's say Reliance or BC Hydro, or depending on where you live, right? In these cases, there are multiple different companies providing energy. So even if one goes down, there is something else, right? One could be coming from windmill, one could be coming from coal, one could be coming from a utility company itself, because they cannot lose power. Dude, I don't have that one particularly. Maybe ask in the Discord. I think somebody else might, because I don't have the one you specifically asked for. Like I'm also using somebody else's account for like certain things. But ask in the Discord. I'm definitely sure somebody will have it.
Historically, businesses would run applications in their own data centers or co-locate with other customers in a shared facility. There was no alternative. Once AWS became available, companies could now run their applications in other data centers they didn't actually own. No more infrastructure to manage, no more repetitive tasks, and time-consuming ones. Goodbye. By using AWS, teams could now focus on innovation.
Oh, there is. Can you send Yuan, then chat with Wrench? He has it. Chat with Wrench. He has it. Then there you go.
And the over the internet part means you can access those resources remotely. You can be in your house, place of business, or visiting family around the world. Hi, Mom. In fact, all you need is an internet connection. Log into your AWS account and manage your infrastructure right from your web browser. And with pay-as-you-go pricing, if you don't need a particular part of your infrastructure, just deprovision it. Simple as that. No contracts, no need to call a sales rep. To reiterate, cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So, as you tackle the rest of this content, keep this definition in mind. Happy learning!
Again, I think you guys understood the pay-as-you-go service idea, that just like electricity or water, the more you use, the more you have to pay, right? You want like maybe ask in Discord, then like somebody might have those things recorded or something. Is like the thing is I'm using somebody else's account. I can't share that. But if ask, do ask in the Discord. That's the thing. But I know it's expensive, man. I know it's expensive. Okay, going back, right? Let's focus cloud computing today. To review the definition of cloud computing, choose each of the following four number tasks. So first one is on demand. On demand means, let's say you want like more storage, more data storage for your database or to store certain files, you can have that. You want multiple servers, EC2 can help you with that, and it's based on what when you need it, right? For example, during the daytime, if you're Amazon.com, during the daytime, right, whichever country, they will need more servers, but at night time there's not many traffic, majority of people are sleeping, you can reduce the number of servers. Never see a coffee shop with the high availability or mounting a cluster of power backup to coffee. Yep. Of the IT resources aspect, highlight the wide array of information technology assets in the cloud computing space. These resources include server storage. So, what basically they are saying, on demand of various services, you have databases, servers, AI, machine learning models. You can train your own models. You can use their specific models. You can even use, like, let's say, vision APIs and stuff, right? All those things you can use, or you can use networking, VPN, anything you like. Over the internet, you don't need like a lot of things. You just need an internet connection and account at AWS, and you can access these things. Just chatting or just send to Wrench. He said something. Pay as you go pricing. I won't say many things about it because some people will get confused. But yeah, basically pay as you go. What we are learning right now is that with time, if you use more electricity or water at your house, you pay more. Same with this. If you are using more servers, more storage, more network, input output operations, more let's say network and bandwidth, or like whatever you are using more, you will have to pay, right? So you got something, that's great. Next, cloud deployment models, cloud-based deployment, on-premise deployment, and hybrid deployment. We'll talk about these things and why all of them are important, and you need to understand these, at least the basics of these for now. You can deploy cloud resources in multiple ways: cloud, on-premise, and hybrid. Each type offers unique benefits and consideration, and exploring these options can help you make informed decisions about the cloud strategy. To learn more about cloud deployment types, choose one of the flashcards. So basically, cloud deployment models. What are these? Let's say you work for a company. This is your company's building. That's stupid design, honestly. This is your company's building. Let's say you work for ABC Corporation, right? Now there is a lot of like people working, right? These are just the windows to show there are people here. Now, if you have servers in the building, or you are the one like maintaining as ABC Corporation, you own the server, or you are setting up a building in the same building, you can on a different building. If you have those servers which are controlled by you, their electricity, their cooling, and everything, you are the one big one controlling this. That's called on-prem. Basically, ABC is the sole owner who is the one taking care of all these, right? Cooling, engineers, heating, water supply, building, on like building security, building land itself, right? That's called on-prem when you are the one owning the server. For example, your computer, that's your on-prem in your own house. You are the one maintaining everything around it, right? That's on-prem. Next, right, is what's it called? Uh, Cloud. What is cloud? For example, in our case, we have AWS. I am inside, let's say, in Canada, in my house, wearing pajamas at 12 at night. I can create, I can use AWS India location and can say, hey, I want to start some servers in here. Now, here's the important thing. I'm not maintaining the land. I did not purchase the land or lease the land. I did not purchase electricity or cooling. I did not take care of any engineering, hardware, or anything. I'm just telling AWS, start a server here. I want to build something. That is cloud using somebody else computer, right? Somebody else. Wait, what is about latency? Yeah, we just paid. Not about latency. Latency is a whole different concept. I'm just saying India, or I can go it in US, or I can do it in UK, wherever in the world. Basically, or even in Canada. I can't type Canada today. Canada, right? In the whole entire world, anywhere, if I start a server where I'm able to do things, but I do not own the electricity, I'm not maintaining the electricity, land, water, heating, cooling, whatever, right? If I'm not, hey Ashish, if I'm not taking care of those things, I'm just telling somebody else to take care of it for me. That is cloud. Hybrid, and this is, I'm going to give you guys a business miracle that was done by Microsoft when Satya Nadella took off, and I was like, had high hopes for Microsoft around that time. Is called hybrid. What is hybrid? Hybrid is some cloud and some on-prem. Is computer of another person or business? Yes, that's actually perfect. So hybrid is cloud plus on-prem. For example, right? Let's say you own a computer, you own a really good computer where you are training your AI models, right? And you have your own website in your own house using Raspberry Pi in Canada. Let's say this is my case. In Canada, I have a Raspberry Pi. I'm putting my own website. My computer, Google, kind of. But let me give you guys this example, right? For example, you have your AI or you have a website. Simple words, you have a website. You are running it on your own computer, right? But now you want to make sure your clients are getting a good low latency, right? They are getting latency, and you don't want people. Let's say this is in Canada, in India, folks in India. If you don't want them to have latency issue and stuff, what do? You say, I don't have a computer in India. I live in Canada, so I can use AWS, start an EC2 server, a virtual machine, and have the same website stored here or running here. CDN is a whole different thing. We'll talk about that later, right? But CDN is like a bit further than virtual machine. But what I'm saying is, now this is on my house. This is in my house, and right, this is in my house in this. So, and I can have like again like some kind of a service. Let's say a load balancer on AWS, or I can have a DNS system. If a request IP comes from Asia, if somebody is requesting my website from Asia, give them the IP address of the website that is running on the AWS server. But if it is coming from North America, direct them to my on-prem website, right? On-prem server, give them that. That is the idea of on-prem. You are using your current on-prem servers plus the servers by AWS or any of these big companies, creating a hybrid architecture. So you don't have a very high bill from AWS, and you are able to use the resources that you have at your house. And this, I will just take a little bit left turn, right, and want to explain why hybrid was very beautiful concepts, and the best cloud to monetize on this was Microsoft Azure, and why Microsoft Azure killed it with it. Yes, you can have load balancer like AWS load balancer can do a lot of things, not just redirection. It can block traffic. So what, for example, let's say if you have a load balancer, Elastic load balancer, I can say if anybody tries to access my website with HTTP, redirect them to HTTPS page. Everything will remain same. But this has to change to HTTPS. I can do a lot of things with ELB. I can block people. I can record their IP address. I can do security groups and a bunch of things. You can do a lot of things. With load balancer, you can have reverse proxy and stuff too. Load balancer is a very, very good. Honestly, I'm going to say one of my favorite networking tools of all time is a load balancer. One of my favorites, especially when it comes to cloud. I love it. Cloud or hybrid depend where your clients are and what need. Hybrid is great if you wish external REST delivery or make 2, 3. Yeah, 2 or back. Yes. Perfect. Yeah, and even like, here's the thing, hybrid. Biggest reason why hybrid was important, and listen to this, what I'm about to say, because this will be very useful and would be a great thing to search after the stream. Why, if you actually search, right, this is something I want you to guys search. AWS starting year. AWS started in which year? 2006. Let's go with Azure. 2010. Let's go with GCP. 2008. 2006, 2008 and 2010, right? GCP was the second one. Let's talk market share of various cloud providers. This is a simple example I like to take all the time. Number one is AWS because they were the pioneers and their service is good stuff. Second is Azure. They came 2 years after Google. And Google, as we know, is an amazing company. Then why Google was third is because when Microsoft introduced their cloud, they took advantage of hybrid like no other cloud did. Why they were able to do it? Because if you remember, on-premise using your on-prem is you have certain resources on in your hand right now that you already paid for, and cloud is resources owned by somebody else. What Microsoft came with the genius idea that, hey, you know what? If your system is running a lot of Microsoft things, you have already paid for the license, right? You have already paid hundreds of thousands of dollars for this license. If you ditch other cloud providers and come to Azure, you don't have to pay for extra licenses. We will have something called hybrid license. And you will save hundreds of thousands of dollars and you will be able to use all the same services. Easy migration, you save money on licenses. It became a no-brainer, and that's why Microsoft was able to grab so many people's attention, even after like 4 years coming after AWS and 2 years after Google. So, why I'm bringing up this story, right, is that to understand if you this whole idea of this stream is so that you can get a good understanding of cloud, various things around cloud, and get a job. If the job is with a company that uses Microsoft technology, hybrid might be your choice. And if it is not Microsoft technology, you might say, hey, we should look for a different cloud. We don't have to be logged in with Azure because of how things are going. You can play once you have the knowledge. Hopefully, this helps you understanding why there are three different models and how there are advantages of this. Is it like a subscription of AWS? They link it that way. No, like services, like I didn't get the same the subscription idea, bro. Subscribe of the AWS, they link it. No. For example, let me give you an idea, right? Windows licenses. Windows licenses. Now you might know there is Windows 7, 10, whatever 11 right now, right? But there is something called Windows Server operating system, right? Cost of Windows Server operating system. Let's see how much is that. Thousand 2000 USD, right? So that's one license. Now another one, let me give you. There is cost for this. There is Active Directory. A lot of company loves Active Directory. They have their cost. They have server cost, and they don't have one server operating system. They have multiple operating systems, right? So these are the licenses. So they have licenses of their softwares, their other services. So they can say, hey, if there's somebody else. So just like in a number of laptops of computers you have to install a Windows operating system every time and have a product key for them every time, right? Same with these servers and Active Directory. Every time you install it on a different server or want a Windows Server operating system on a different server, whether it's in cloud or your local, you have to pay for that license. Microsoft said, hey, you don't have to pay twice. If you already have a license on prem with us and you use the virtual machine on R1, then we do it. Yeah, Office too, right? They don't have to pay Microsoft Office. So, yeah, in 400, 600 offices, like, for example, like a university. Wait, Open Map? What's Open Map? Oh, I don't know about that. But yeah, basically like these type of licenses, like the software license I was talking about. Hopefully that gives you the idea. Oh, the link are not going to be shown. You have to put it in can you put in the what's the name? Just chatting, yeah. Can you put in here, Almiva? Oh, 365maps.com. Oh. Okay. Oh, wow. So this has all the information about them. That's actually cool. A collection of micro licensing diagrams, feature comparison. Oh, nice. That's actually cool. That's actually cool. Yeah, this is a great one. Thank you so much, bro. I'll share with other guys right now. Thank you, Almiva. Yeah, but this is a great resource right here. So yeah, you can compare, you can see like which ones are working and stuff like that, right? I had no idea. You guys have so much good resources, damn. But yeah, that's what the whole idea I was saying. Like, so people don't have to pay for multiple Active Directory licenses, server operating system licenses, and stuff like that, right? Instant $100,000 of saving. Why you won't take that? Okay, we'll do that. We'll cover all those things. We'll cover those things extra. I want to like move as much as possible in this because I know this is a 12-hour course already. So let's go over the 3 deployment models. Remember, there are various models, various options and models, right? Depending on what it is, deployment model, service as a service model, and what other things. Okay, nice. Okay, cloud. In a cloud-based deployment model, you have flexibility to migrate your existing sources to cloud, design and build new application within the cloud environment, or use combination of both. Cloud-based. On-prem, deploying resources using virtualization, right? One server you have doing multiple. In hybrid, cloud-based resources and on-premise infrastructure work together. Simple. Basically, cloud, all AWS. Every single thing is on AWS. You don't have anything on your computer or in your building. You don't maintain anything. Just everything is on cloud. On-prem, you maintain everything. Third, hybrid, you are doing 50-50 or 30-40. Something on both sides. What is LLD? I have no idea. So now answer this question so I know you are able to get the understanding. You work for a local charity organization. Your organization has sensitive data that must remain within your country for compliance reasons. So this is great. India comes up tomorrow with a policy that the data, right, cannot leave India, right, for compliance reason. However, you also need solution that can scale quickly to handle seasonal spikes in demand. India, let's say in summer you get more spike versus here, and the data you are saving is the credit card one. It cannot leave India. You'll decide to keep on-premise resources for compliance and use cloud-based for dynamic scaling. Which type of model is that? No, you don't need to learn Kubernetes or Docker if you want to play in cloud. You legit don't need anything like that. Let's answer this one, please. If you want to use on-premise sources like this database is on-premise to keep your data according to compliance, yes, hybrid. Thank you, Bob. Next. Benefits of AWS Cloud, 6 key benefits. I don't even know if I want to watch that video or not. How long is that? Okay, 5 minutes. Let's watch a quick video of this. I'll also rest my throat.
Okay, you have a good working definition of cloud computing, and you've also touched on why it's beneficial from a business perspective. Now you'll learn even more about the advantages of using a cloud computing model. We'll cover 6 primary benefits of the AWS cloud. Let's start by talking a bit more about that first concept we've mentioned, the ability to pay as you go. With the cloud, you can trade fixed expenses for variable expenses. Remember when we talked about how data is housed in a data center? When you're building a traditional on-premises facility, you typically need to invest a large amount of money up front. This includes investments in physical space, hardware, staff, and upkeep to make sure everything is running smoothly. For some businesses, this can be hundreds of thousands or even millions of dollars. Then, regardless of the data center's utilization rate, you have a fixed cost,
and you have to set up your budget around that fixed cost. Billing with AWS is fundamentally different. Your bill with AWS will be variable from month to month as you consume different amounts of resources. The great thing about this model is that if you're just getting started, there's no need to come up with a big investment to build out your AWS environment. Instead, you can start small and get billed for only what you use, and you can use built-in billing and budgeting tools to find ways to save money every month as your business grows. So that's the first advantage. The next advantage is that you benefit from massive economies of scale. AWS is building data centers all around the world, and in order to build all those data centers, AWS is buying a whole lot of hardware. Because AWS buys a good amount of hardware, we can purchase this hardware at a lower price. Then we pass on those lower costs to the customer. The next benefit? Stop guessing capacity. In a traditional data center, you purchase hardware based on projected usage. Let's say you estimate you'll have a user base of 10 million people over the next 3 years. That means
Rover, what's up?
you purchase enough hardware to support that growth over time. But what happens if, when that third year hits, you only have about 500,000 users? You're still stuck with the hardware you purchased to support 10 million users. Let's flip the script. Imagine you underestimated your capacity. A growing customer base is great for your business, but the scramble to secure more hardware could be a real problem. You would need to rapidly procure more servers to handle that higher capacity. If you don't adjust in time, your customers could have a degraded experience, or you might even lose them altogether. This is the awesome part of AWS. You don't need to guess capacity. Scaling usually takes minutes instead of the weeks or months it can take in an on-premises data center. You provision needed resources for the present. Then you use scaling mechanisms to scale these resources up or down based on the day-to-day demand. The next benefit is my personal favorite: increased speed and agility. With AWS, you have more bandwidth to try new things. You can spin up test environments and run experiments, trying out new ways to solve a problem. And then, if that approach didn't work, you can just delete those resources and stop incurring cost. That way, you can spend less time provisioning and deprovisioning and more time innovating and optimizing. All right, next up, stop spending money running and maintaining data centers. We've talked about the upfront cost of data centers, but there's more to it than that. Apart from the fixed cost of what it takes to build out a data center, AWS eases the cost of running and maintaining servers. This means instead of spending time and resources focusing on racking, stacking, and powering those servers, you're spending more time.
Okay, I'll explain all these things, right? And I might use my own. The 6 key benefits of AWS clouds are as follows. And let me just hand, because I might get some stretching while we are at it. Yeah, and there is a lot of interesting things that will happen though. I think it depends on once you start looking at the business sides of things, even though they are not new, it's important. Man, I hate these fake AAA Corp videos. Yeah, dude. Yep. So, here. Trade fixed expenses for variable expense. Now, here's the thing. Of course, a lot of you might even ask questions about things that make sense to have on-prem compared to on-cloud. Why on-cloud is important, and let me put this very clear. Why cloud is more important and way more, I will say, popular compared to on-prem is because a lot of startups, when they get money, right, their focus is on creating the best software and bringing in customer value instead of spending and how they can create the best software by spending the money they got from investors into getting more engineers for app development, rather spending it on the GPUs and stuff, right? You only want on-prem when you have a lot of money, you have engineers, and you don't want to be like on the mercy of just some servers or like some cloud company, right? Here, trade fixed expenses for variable expense. By using AWS Cloud, businesses can transform from fixed investment to variable cost. With variable cost, customers' expenses are better aligned with actual usage than creating more. So, for example, in a startup, remember, cloud is the best for startups, right? Compared to big companies. So, you are, let's say, today, let's say you are the next ChatGPT of Canada or India. right? You are just serving in one country right now. When do you think will people use your app more? During daytime or nighttime? Well, again, depending on the type of app, but let's say it's a very good app, legal app for educational purpose. Majority of the people will be using your app during the day, right? So you want more servers. Let's say you want 10 servers during day, but nighttime your traffic goes very low. So you might need one or two servers, right? At nighttime. That's the thing, right? You might use it at night, but majority people will use it at during day for schools and stuff, right? So trade fixed expense versus variable. But if you're using cloud, you can do this. In morning you can have 10 servers, at night time you can have one or two. But if you purchase 10 servers, you always are using them 24/7 and you are paying for them 24/7, which means you are paying for the electricity, cooling, engineer on site, so that if any of the servers goes down, you are paying for the security guards right outside, so nobody can just come bomb your data center, which some people have tried doing for AWS. So Kubernetes is the best for this case, right? It will pop up Docker. No. That's one. You don't even need Kubernetes. That's what I'm saying. Don't worry about Kubernetes or Docker right now. Trust me, once we go, I will teach you every single thing. Right now, just focus on CCP, because I will teach you so many ways to create different servers and have like demand taken in control. Don't you worry about it, because the answer for that is no. Answer for that is no, because there are so many ways and so many better ways to use that. Okay. So that's what they are saying. This is fixed cost. You always have to pay for 10. But this is variable. In morning, you have to pay for 10 for, let's say, 8 hours. And rest 16 hours, you only pay for 1 or 2. Right? So that's the first benefit. Fixed cost versus variable cost. Next benefits for massive economy of scale. This is going to be a question in your MCQ, I can damn assure you. This is like a word created just for cloud. Like buying a product in bulk can result in lower prices, just like we go for market buy bulk of like potatoes and stuff. The vast global infrastructure of AWS can result in lower cost for customers. This means that AWS can be used by many organizations, from small startups to major corporations. Businesses big and small can access advanced technologies that are previously only accessible to large enterprises. Here's what it is. Economy of scale. Because AWS is buying so many servers, so many GPUs, they are able to get discount from their vendors, and that discount can actually apply to you, right? As a startup, you can't afford like $40,000 H100 NVIDIA GPUs. But if you want to use them, you can use them for just couple $100. That's what they're talking about, because AWS is able to buy things in scale and use it, and a bunch of startups like yours or others want to use the same thing because of the shared economy, shared resources. Using the same CPU server by multiple people, you can get that advantage, right? Simple. Think about that way, right? Now it should make sense. Bulk result in lower prices per unit. So AWS buys a bunch of things, and that can be resulting in lower cost to the customers. Simple. And you can, if you are using, like, let's say, another thing with AWS is, if you are buying a lot of server, you tell AWS, hey, I will be using hundreds of servers for sure for the next 1 year or 3 years. You can get a discount on that too, which is a great thing. You can get 60%, up to 60% discount on those things. I recently signed up for a 3-year one. I legit know it's 60%, 50 to 60% easily. Okay, going back. Stop guessing capacity, right? Now, you are a startup. You don't know when the bomb will drop. Basically, you don't know when you can get like very, 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 very popular, right? Or what is that? Otro Anuchinio? What? Well, okay. Let me. You have to translate that for me, boss. But basically, just like YouTube channel, right? I don't know if I can like tomorrow get like super popular and get million views, right? Same thing with your app. You don't know when you can like get really good demand, right? What can happen? So what you want to do is you want to have good cloud computing. If you have good cloud computing in place, the name technical term is scalability. You can scale. Oh, gotcha. Thank you, bro. But scalability is basically, let's say you are using 2 or 10 servers. Usually you are using 10 servers for your edtech platform, right? 10 servers during the day for your ed tech platform, like a YouTube one. All of a sudden, a lot of people start talking about it. There's a buzz around on Reddit, Facebook, YouTube, Twitter, wherever, right? So many people, and you all of a sudden, instead of like getting a million people on your website, you get like, let's say, 100 million. With something called scalability, what you can say is, hey, I can scale horizontally, which means if I had 10 servers, I can add 20, I can have 20 servers, 30 servers, 40 servers. Horizontally means more servers, or I can make my servers even more powerful, and that's called vertical scaling, where I had a small server with, let's say, one small GPU, one virtual CPU. Now I will have a very powerful one. Horizontal scaling is better than vertical scaling, just letting you know, majority of the times. But this is another benefit of AWS. You can have scalability. You can have multiple servers as soon as demand hits with proper programming in place. Increase speed and agility. With the cloud, businesses can rapidly deploy applications and services, accelerating time to market, facilitating quicker responses to changing business needs and market conditions. Let me put this way. Wait time on NVIDIA GPU. So you need amazing NVIDIA H100 GPU chip tomorrow. You can't get it. It's 2 to 3 months wait. That's how much the demand is. You can't just go to a store near you and ask for it. It's a $30,000-$40,000 and 30,000-40,000 US dollar one, right? So what they are saying here, increase speed and agility is like, hey, speed and agility. Hey, AWS, I am AWS. I already have 20 of these, right, in my servers. You want to use one? With one click, almost, or within 1 minute, you can create a server that uses this. That's how what they mean by scalable, speed and agility, right? And if you don't need it like tomorrow, you can, with one click, you can turn it off. AWS is amazing, but needs skills. Without architecture, beginners don't know. Yeah, that's what I'm saying. Almivar, stay with me. I think if you guys like this, if I get a good response on YouTube and like you guys want, I will teach you how to build architectures. I will teach you how to do this. But that's my job, legit. That's my specialty is. That's legit my specialty. Jenkins, understand, helping you set up Jenkins server, helping you set up the CI/CD pipelines with Jenkins, GitHub Actions and stuff like that. I can teach you guys these things, and I might learn some couple of things too. So it would be nice. But you are very much true that it's amazing service, but you need skills, architecture. But again, with time and practice, you can get it. Like AWS is just like hacking; it only will come with practice. You can't just have theory, theory, theory. We need theory so that people who are about to go into the, you are students or looking for a job, this certificate, having a certificate, having this AWS CCP badge will help you. This badge you should have on your resume and your LinkedIn. Okay? Stop spending money to run and maintain data centers. This is a good one. This is a good one. What that means is, right? Beauty about AWS or cloud computing in general is that pay as you go. Majority of the cases is pay as you go. I can pay for just 1 hour of service and get the heck out. I can pay for 1 month, 1 year, 3 year, 10 year. I can get the heck out anytime I want. It's on demand. Just like YouTube. You don't have to watch 1 or 2 hours of video every time. You can just watch 5 minutes. You can watch 3 hours, whatever you like. Whereas in case of data center, right, the case is if pay as you go services, right, with data centers, if you want to just set up a data center, you know what you need? First, I showed you the GPU, right? You need like 2 to 3 months of wait to even get a chip. Then you need land, you need electricity, you need engineers, software engineers, server engineers, you need network engineers, you need engineers, so many different type of engineers. You need water for cooling and stuff, proper air conditioning and stuff. You need security people to help like secure, like the security guards and stuff. These are the things you need to even set up one server, right? But if you are a startup, you don't have to worry about these things, or even as a big company, all you care about pay as you go. I have the service, I'll go. In one click, I can get the starter, I can test my app, and I can heck leave. So that's what the beauty about, one of the biggest beauty and one of the biggest power of cloud is. You don't have to maintain physical infrastructure. Your focus as a startup is, I want to develop an app. That's all I care about. I do not care about maintaining all these 20 billion parameters, right? And that's why cloud is important, because now the world is changing with AI. So many startups are coming. Everybody wants to get in on the action. If you have skills and if you have certificates to show and prove that you have skills, you can get a good job. So please focus on this. Okay. And thank you for focusing today. I know like crazy questions are coming, so I'm really glad. Thank you for listening to me. Go global in minutes. Another beautiful thing. You, right? If you get, let's say you have servers in Canada. If I am a startup in Canada, yes, sir. So, start up in Canada, right? If I'm a startup in Canada, but I have a bunch of clients in India, right, who are like into ed tech type of stuff. A lot of parents want their kids to learn AI, and I'm an AI teaching ed tech company. If I want to set up a server in India, you know what all things I need. First, I need a bank account in India. I need proper papers. I need somebody in India, hire somebody, so many Indians, right? Or people who can go to India, so many things, right? But with AWS, I can just change my location. I say, hey, I want to set up a server in India. Done. They will ask which city, Mumbai or Delhi. And if I have more people in Delhi, I can just set up. If let's say from EdTech in India, now I get more traffic in Singapore. Heck, in minutes I can move everything to Singapore. Those are the 6 things very important for your exam, because when I gave the exam for Azure, same things were asked. You just have to remember the term, understand them, not memorize or like do a whole ratta of these. Just like understand, okay, economy of scale, so many people, so many startups, benefits of bulk, right? A retail business plans to launch a new line of clothing, but they are struggling with accurately predicting how much server capacity they will need to support launch. Which benefit of AWS is most relevant in this situation? You guys have to answer. So you guys don't know how good the business will be for new clothing. You don't know how many people hits you will get within a day, 2 or week. What is the right one option? With AWS, what advantage you get? Stop spending money to run and maintain data centers. Stop guessing the capacity. Trade upfront expensive for variable expense. Go global in minutes. Here, the main thing is struggling with the accurately predicting how much server capacity they need. This is the main thing. This is the main hint. This is a very legit question they can ask. With all our benefits, which benefit will go in this situation? Let's come on. I need answers. Stop guessing. Yes. Nice to see you, man, Almivar. Thank you so much for joining, mate. And see you tomorrow as well. I'll be coming tomorrow. Okay, how much we are in? We are in 1.5 hour. That's amazing. Okay. Global infrastructure. Okay. Okay, let's give me like 2 minutes. Let's take a 2 minutes break. I'll go to washroom quickly, right? I'll play the song, and yeah, let me just play the song. We'll go. I'll go to washroom. You guys also take a quick break, and then we'll get back into this. Okay. Thank you so much, lads. Just 2 minutes break. 1 second. How do I do that? Thank you, Almivar. Thank you so much, mate. Spam YouTube feeds. Yeah, go for it. Thank you, man. Okay, cheers, lads. I'll be back in 2 minutes.
Atera is the IT painkiller.
Okay, I'm getting an ad on my own thing. 1 second.
In the wires, we're the ghost. Ego's king, we rule the host. Masks on screens, we wear them proud. Silent hands inside the cloud. Flicker in the firewall glow. Name in red on a watch list road. Every trace that they think they own, we erase, turn it all to smoke. Hack the world, that's the dream. Pull the thread of the global scene. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the crack machine. Hack the world, the final scheme. Wish the system, break the code. Watch the virus overload. Black hood up, eyes run cold. Turn the silver into mold. 10 fake memes on a single wire. One small spark, whole grid on fire. Who owns what when the locks all fail? Who holds power when we lift the veil? Heartbeat sync with the scroll. Cursor dancing on the soul. All their walls built tall and proud. We just walk straight through the crowd. Hack the world, that's the dream. Pull the thread of the global scene. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the crack machine. Hack the world, the final scheme. Are you in or out tonight? Ride the edge or run from sight. When the curtain tears in two, will the ghost look back at you? Hack the world, that's the dream. Pull the thread of the global scene. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to ring. From the core to the crack machine. Hack the world, the final scheme.
Okay, I hope I don't get any issues with that. Alrighty, I'm back. Howdy, howdy, howdy. Thank you so much, Almivar. Peace out, bro. Have a good day. Okay, you guys back? Hola, hola, hola. Hello, hello. Yo, you guys back? Should we get started? I want to finish at least 2 modules or 3 modules today. I'm not. Had a boy, man. Had a boy. Okay, who all are here? I think the question is who all are here and are you ready to get started? Are you learning something, at least like something able to like revise certain concepts? Okay, let's do it. Okay, so in this lesson, you will learn about the basics of AWS global infrastructure. You learn about the unique physical setup of AWS resources. You explore some benefits of AWS infrastructure, such as high availability, fault tolerance. You will learn about much more advanced concepts of AWS infrastructure in a later lesson of this training. Basically, we'll learn about how the infrastructure is set up and why AWS is a secure place if you want to make sure your app you are building is safe and sound no matter what. Right? This is what it is about. And you are going to learn about availability zones and regions, which is very important. Okay, so let's get started with this video first.
Let's talk about the AWS global infrastructure. You've already learned that AWS builds and maintains data centers around the world that you can use to go global in minutes. But there's a huge advantage to global reach that we haven't covered yet, and that's high availability. To learn a little bit more about high availability, let's head back to our coffee shop. Say you've hired a new employee and they're learning how to make a latte. They're doing awesome. They've got the right milk to espresso ratio, and they are even making some cool designs with their latte pour, until they miss the cup and they pour the latte all over the register. That is not good. The register is now fried, and it seems like it shorted the electricity everywhere in the shop. Yikes. That means we can't bring up orders or make drinks for our customers. We're gonna have to close up shop until
Women.
this is sorted out. So, what does that mean for the business? Does this mean that the entire business isn't making any money until this is fixed? Well, luckily for us, we're prepared. The good news for our business and for our customers is that this isn't our coffee shop's only location. The shop is actually a chain, and we have locations all around the city. Customers can still get their coffee by visiting one of our shops just a few blocks away, and the business can continue even if one location is having a bad time. So, whether an employee had a slight latte mishap, or a shop next door accidentally cut our internet line, or some other disaster keeps the shop from its day-to-day operations, no matter the reason, we know that our product will be highly available for our customers. They still get their coffee, and the business is still generating income. All is well. AWS has a similar setup with our global infrastructure. It's risky to have one giant data center where all of the resources are housed. If something were to happen to that data center, like a power outage or a natural disaster, everyone's applications would go down all at once. You need high availability and fault tolerance. Let's clarify those terms. High availability is all about making sure your applications stay.
This is a hacker term as well, remember, because CIA triad, right? In hacking, confidentiality, integration, and availability. High availability, those are the same availability. If one server goes down, if a hacker took over one server, there are other servers ready to serve your clients.
Accessible with minimal downtime. Even if one component fails, another is ready to pick up the slack so your service keeps running. Fault tolerance takes it a step further by designing a system to continue to operate even if multiple components fail.
What this means is one location went down. But what if, right? Fault tolerance is, let's say, if I have all the things I want, like for example, if all my majority of my clients are near Delhi, right? If I'm building a trading app, majority of my clients are near Delhi or Mumbai. If electricity for once one of the servers is gone, or one type of electricity is gone, for remember I had wind electricity, water dam related electricity, or the utility company, right, that was serving me through government or stuff. If even one of them goes down, I have fault tolerance. I'm not reliant on one. I have other two, three to fall back to, right? So I can't go down that easy. Same as like with your cars. When you are traveling, you have four tires, but you have an extra one. Just in case on highway, one of them goes down, you have an extra one to fall back to, right? And make things work still. That's the same idea here. If one of the things goes down, there are fault tolerance, there is system in place so that the things can still keep on moving. Availability, if a natural disaster occurs, right? For example, a easiest way to explain is, this is all you guys have seen. You want to go from point A to point B. Summer is going on, a lot of like during, at least in Canada, during winters, because of snow, we can't do a lot of um, road maintenance, right? Filling up the potholes. But let's say there are three ways to go to location B, right? For example, this is the shortest one, right? Then this is the second shortest, third shortest. There are three ways to go. Now, first one, because of certain issues, the first one can't be used because it has potholes being fixed, right? There is block or some kind. Second one also, because of some riots is not going on. There is still the third one going, right? You might be like, third one, there is S4, S5, there are hundreds of these. That's the same idea. If one server, right, now think of, instead of location, if there is one AWS, right, a client wants to reach, or your client wants to reach your server at location B, or your app, one server can go down in Mumbai, one server can go down in Delhi, there could be one in Chennai, another place, third location, so people can still get access to your server or the app. That's what availability is. No matter if one natural disaster happened, two natural disasters, still it's available, still there is things. That's availability. Different location, if one whole location goes down, one whole server is done, there's still other ones to fall to have. Tolerance, if one of the components goes down, instead of whole location component, one of the things goes down, there's others to fall back to. They are very close related. Just going to let if you are like, oh, they are very close, yeah, they are very close concept.
It's basically building resilience into every layer so that no one single failure brings down the whole system.
One server has issues regarding, let's say, we are updating Ubuntu. Google is still working, right? There are multiple servers Google have, so Google is updating one of their servers. There are still many others to help serve you.
Designing for high availability and fault tolerance is part of the reason why AWS operates in regions, which are located in different areas around the world. These regions are built to be as close to AWS customers as possible. This includes locations like Paris, Tokyo, Sao Paulo, Dublin, or Ohio. Within each region, we have what we call availability zones, or AZs. There are 3 or more AZs within a region for redundancy. We don't build AZs right next to each other because if something like a natural disaster were to occur, you could lose connectivity to everything in that AZ. And continuing with the theme of redundancy, within each AZ, there is 1 or more discrete data centers with redundant power, networking, and connectivity.
Here, if, for example, let's say if you are in Delhi, Ohio, anywhere, right? Delhi is a very big one. there is a very big place, right? You might have one server in North Delhi, one in West Delhi, one in South Delhi. So they are separate. If something happens in one, right, a natural earthquake happens in one, other two are still safe, right? Same with Mumbai, where or any like location near sea, right? Tsunami happens at least one. It's still like hundreds of miles away, so tsunami just can't reach there that easily.
With redundant power, networking,
It's
and
not like it's impossible. The probability is super low, super low.
connectivity.
And what they're saying about power, networking, connectivity, power, there are multiple ways to get electricity to your servers, right? One could be wind, one could be, let's say, through the company utility. So they have multiple ways to get power. If one goes down, wind, there is no wind, there's windmills are gone, there's still utility company dam is there, so many things are there. Connectivity, networking, optic fiber, satellite, so many things are there.
So, if
That's what, when money is given, engineering can be super beautiful.
a region is where all of the pieces and parts of your application live, some of you might be thinking that we never actually solved the problem that we presented earlier. If my business needs to be disaster-proof, then it can't run in just one location. Well, you're absolutely correct. That's why it's common for businesses to operate across multiple regions. That way, if one region is experiencing outages for any reason, the operations can fail over to another region. But we'll cover that more in depth in a later lesson. In the meantime, I'm going to sit back here and relax because I know that my business is highly available, regardless of any disasters or spilled lattes.
Doesn't mean you have to spill lattes everywhere, just letting you know. Okay, regions and availability. Region is the big same as like a geo region. Delhi, Mumbai, Ohio, Vancouver, Toronto, right? Stuff like that. So global infrastructure consists of physical location around the world, right? Physical location around the world that contain group of data centers. So one region will have multiple data centers, and these group of data centers are called availability zones. Each AWS region consists of minimum of 3 physically, so it can be more than 3 depending on some of the popular more heavy places. So for example, Delhi and Mumbai, heavy, they might have like 3 or 4 or 5 availability zones. But somewhere, let's say maybe in Australia, near Australia, not that much population compared to India, less, right? Same thing. Physically separate availability zones within a geographic area. Now, within availability zones, and you can select while setting up your server EC2, they ask you which availability zone you want to set up in. An availability zone consists of one or more data centers with redundant power, networking connectivity. Regions and availability zones are designed to provide low latency, fault tolerance to services for users within a given area. Engineered very well. It's beautiful just to see it. Achieving high availability with AWS Global Infrastructure. AWS infrastructure is designed with high availability and fault tolerance in mind. You don't have to worry. Trust me, engineers who are paid $1 million a year minimum have designed these things, and they are very brilliant people. Availability zones are configured as isolated resources, and they are each equipped with independent power, networking, and connectivity. It's recommended to distribute your resources across multiple availability zones. Why? If due to disaster, earthquake, the whole data center went down in one of the regions, right? Or like landslides happen, this is all gone. This two are still good, right? Or somebody tried to bomb one of the availability zones thinking it will take down the internet, other two are still good. I'm not joking about it. It actually happened. 2025 was amazing in its own ways. If one availability zone encounters an outage, your business application will continue to operate without interruption. With this approach of redundancy and resource allocation, isolation, AWS customers can achieve benefits of high availability and fault tolerance. I don't know how much you have watched a very beautiful clip from This is where Mark Zuckerberg, right, is mad at his partner because he froze the server. Facebook went down, and he said, "We are not same as any other company. Facebook never goes down." That's what redundancy and fault tolerance is. Have a look.
Okay, let me tell you the difference
Hey,
between
Panda.
Facebook and everybody else. We don't crash ever. If the servers are down for even a day, our entire reputation is irreversibly destroyed. Look, users are tickled.
We don't go down ever. Hey, Panda, how you doing? So if you have the same passion when you are building an application, you care about your reputation so much, redundancy and fault tolerance are something you cannot miss. Any startup at this point cannot miss that. You just joined a tech startup, the business is growing rapidly, your new company decides that they need to design a resilient, scalable infrastructure on AWS to handle increased traffic and help ensure high availability. Which statement best describe AWS cloud infrastructure benefit of high availability? Answer. I accidentally clicked this. It's not that. Oh, hope you get better soon, boss. Hope you get better soon. So I will read the options for you guys. AWS stores all the website's data in a single AWS storage bucket to centralize data management. Centralization is not a good thing, always. AWS has many customer support options to ensure answer to questions. Provides multiple data centers across different geographic location. Offers high scalable secure data center that can handle all your traffic. Which one, lads? Number 5? Perfect. That's wrong. There is no number 5. Come on, bro. I have already done up to 5 module, man. Oh, okay. Then answer this one. What's the answer for this? Three. I'll just go with this. It's too late. Wait. AWS shared responsibility model in this lesson. In this shared responsibility model, describe and differentiate between customer responsibility, AWS responsibility, and shared responsibility. This is important if you want to understand which, depending on your case, especially if you are going to work for a multi-billion-dollar organization, and this is where SLAs, compliance, security come into place. And also you can save a lot of money if you understand these things. Describe the components of the AWS shared responsibility model. I won't go through these videos. I think they are just wasted of time, honestly. So the AWS shared responsibility model is a concept designed to help AWS and customers work together to create a secure, functional cloud environment. In this lesson, you will learn about the components of AWS shared responsibility model. With a clear understanding of cloud computing responsibilities, organizations can better navigate complexities of cloud security. So, what this means, right? You are a new, let's say, startup in America, New York, New York City, right? You have a lot of clients there. You want to use AWS services there, AWS servers, right? And AWS servers has multiple AWS data centers and availability zones have multiple servers, big racks. You can't just, in these big racks are the ones that actually have multiple EC2 instance running, multiple databases they are holding. So you are technically sharing the chips, those NVIDIA chips, those Intel chips, those AMD chips. You are sharing the storage. They are not going to have one terabyte of just small 1 terabyte of storages, right? They will have like 1 petabyte of storage connected to the server, and then they will divide it so that 10 100 different startups can use, right? That's the basic concepts what happens at a data center. So customer responsibility is, make sure whenever you start your EC2 server, right, the customer data, client side data encryption, so your data is encrypted on EC2 whenever like there is communication happening from your app or which is on AWS server through EC2 servers to the client is HTTPS, not HTTP, stuff like that. Security in cloud, client side data encryption, client side customers, right, you are their HTTPS, not HTTP, stuff like that. Customer or AWS, this depends on what type of service you are using, and that's what AWS take care of. Server side encryption, if you are using a PaaS or SaaS, platform as a service type service or software as a service, you might be provided with service side encryption. But if you're using infrastructure as a service, EC2 server, you might or might not have server side encryption. Network traffic protection, same case. Platform and application management, operating system, network, firewall configuration. If you get an EC2 server, you can choose which operating system you want, and you can tell, hey, you have to mention your own configuration. AWS is not going to touch it, it's your responsibility. In case of AWS responsibility, which always going to be their responsibility, software for compute, software data and networking. So there's going to be some firewalls for data that's coming into this, so they are going to maintain that. A software virtualization software, so somewhere multiple startups can all run their servers on one big stack, server stack, right? Hardware, electricity, the chips itself, storage, actual those SSD drives, stuff like that. Those are AWS responsibilities. Remember, this is always going to be your responsibility, the first one. Third one, always AWS. Second one depends on the type of service you are choosing. You work for a startup company that is developing an application in cloud. A new security update is available for your operating system, and you are tasked with verifying the operating system that is patched, right? Accordingly. What best statement describe? You are tasked with verifying that the operating system is patched accordingly. Okay. Which best describes the part, which part is responsible for applying security patches? AWS is responsible for applying security patches on the operating system. Sure, your company is responsible for applying security patches. Both AWS and customer apply separate patches. Operating system vendor doesn't care. It's depending on the situation. We do. Your company is responsible for applying security patches. It's customer and depends one. Oh, for our operating system, okay. For us, our operating system, we have our own license and thing going on. My bad. Okay, that's cool. Send the link. Send the link. Nice, bro. Send the link. Okay, where we at? I think we are at the last. Yeah, and we have just assessment after this. Applying cloud concepts to real life use cases. Explain how fundamental cloud concepts such as AWS global infrastructure and shared responsibility models work together to form real world business solution. My PCI is going crazy now. I will add the models directly. Thank you, bro. You learn about this. You learn about some fundamental cloud concepts like how cloud computing works, the basics of AWS infrastructure, and shared responsibility models. It's important to build your knowledge of cloud computing piece by piece. However, in reality, the concept you learn about in this training work together, not separately. In this lesson, you will explore first example of the cloud in real life, piecing together how abstract cloud concepts work together to drive innovation efficiency in your business. So let's look at this one. This video, let's look at this one.
Hey everyone, welcome to a segment of this training that we call Cloud in Real Life. Every once in a while, the three of us will come together and take the concepts you've learned and explore how they work in real world, real life scenarios.
Exactly. So instead of just talking about features and definitions, we're going to think through how businesses or individuals might approach real world problems.
And this is super important because this course is for anyone trying to learn about AWS, including beginners. So we've purposefully simplified a lot of the AWS concepts to make them digestible for someone just getting started. With these cloud and real life segments, we'll talk.
I understand. I'm just going through this one because I want to know what they're talking about in real life. What is this? This is not. Best, I think, scientifically, yes. Practice, talk, have some good memories.
Talk about how these basic concepts turn into real world solutions for businesses.
Oh, wait, shall we kick things off with an example?
Yeah, let's do it.
Okay, let's
Keep
take
going
two
on.
concepts we've discussed in the section, AWS Global Infrastructure and the AWS Shared Responsibility Model. In the real world, these concepts certainly work together and aren't separate ideas.
So true. Let's use an example of something like about an e-commerce company, one that wants to expand operations globally.
Yeah, I like that example. There are tons of e-commerce companies that use AWS. In general, how would using AWS Global Infrastructure benefit a company like that?
Well, one thing to keep in mind is that the further your infrastructure is from your customers, the longer the latency will be for those customer requests. So they could choose AWS regions to host their application closer to their customer base. For example, if they have a significant customer base in Europe and Asia, they might choose to deploy their applications in regions like EU West 1 in Ireland and AP Southeast 1 in Singapore.
It's so much easier to reach a global audience when you're leveraging existing resources like AWS regions. The groundwork has already been laid. And even though all businesses benefit from this, I also can't help but think about startup companies and how much you can achieve with a small team by leveraging the cloud. You don't need to have a large upfront capital investment to reach a global audience, which can really help to level the playing field a little bit for startups and small companies.
Oh, that's so true. And also, it's a lot more straightforward to build resiliency into applications. For the e-commerce company, they could start by using at least 2 availability zones, or AZs. They deploy the same configuration
His hairs look like shakalaka boom boom pets here. I'll show you.
in each, and if one fails, they can fail over to the other. This is called designing for high availability and fault tolerance.
Now, we haven't talked about the importance of multiple availability zones too much yet, but we'll get there soon. Now, we also learned about the AWS shared responsibility model. So how does this come into play here?
Yeah, the shared responsibility model is super important for understanding security and compliance. Our e-commerce company can focus on the higher order issues of securing their data and managing access to their AWS resources. Plus, they'll be able to give attention to things like making sure their applications are configured securely to comply with regulations about credit card information, rather than having to decide what locks to put on the doors at the data center.
Right, the whole in the cloud and of the cloud situation. AWS is responsible for security of the cloud, and customers are responsible for security in the cloud. AWS services are used together like building blocks to form solutions. So this concept of the shared responsibility model will become clearer as we see how different services are used separately and together.
Yeah, and there's so much to learn, and we will have more meaningful discussions as we go along.
Okay, good. So let's see what they are talking about. Cloud in real life infrastructure and shared responsibility. In the preceding video, you examined how AWS cloud infrastructure and AWS shared responsibility work together for your business solution. For this use case, the global e-commerce company, for example, Amazon, they are giving their self a pat on the back, deployed resources to multiple AWS regions and availability zones. To learn more about the benefits this infrastructure design achieves and how AWS blah blah blah. So we have one in e-commerce company expansion. They started in US, Seattle, Washington, but they got more people, let's say in UK. So they have started one in Europe West 1, which is in Ireland, and something for Australia and stuff in Asia too. That's it. Like basically they have created servers and application available in various places. Okay, the time for assessment. You must score 80% or higher to pass. Okay, a small business is considering migrating their IT infrastructure to the cloud. The finance team has a meeting with the IT department to discuss the costs associated with this transition. During the meeting, the finance manager says they will like the idea of reliability that comes with the cloud, but they are worried about the fixed cost. Which statement accurately defines cloud computing model and addresses finance manager's concern. So basically, migrating fixed cost concerns what will be the cost of the things, right? Because it's not fixed, it will be variable. Reliability is one of the things. So it's going to be talking about like how variable and other type of costs are associated with cloud. Cloud computing is basically just using someone else's server to host your website, and it does not offer any sort of significant cost advantage over traditional ones. This is wrong because the second part, it does give advantage because you don't need a lot of capex. So there are two terms I want to explain to you guys. You will learn this or you will hear this a lot, right? Capex versus OPEX. And you probably already know what this is. Capital expense, right? Or expenditure. So basically when you buy servers, chips and blah, 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 you need capital for that. And operational expenses are less. You still need to have operational expenses. For example, when you are setting up your own data center, you still need servers, electricity, all those, right? So there will be a lot of capital but less operational. With OPEX, there is zero capital. It's all operational. Good part is if you don't have a lot of money to put and you're testing the waters, with cloud you can do testing the waters, right, easily. So that's why the second one, traditional, which is on-prem, it does provide a big advantage. So you don't have to go super above the budget. You can't control it. You can control things. Cloud computing involves purchasing dedicated servers and setting up private data centers. Nope, that's totally wrong. Cloud computing reduces the need for additional hardware, but still involves significant fixed monthly fees. Yes, it still has fixed monthly fees. If you buy certain plans, it has almost like a fixed one, but not 100% fixed. Cloud computing is a model for delivering IT resources over the internet. Perfect. Business can rent services using pay-as-you-go basis. Yes. Which can help reduce fixed cost and allowing more flexible budgeting. Yes. That's the best one because, as I mentioned, significant fixed monthly fees. Yes, there could be significant fixed monthly fees, but it's not 100% fixed. It's still variable. You can only have up to a limit of fixed, right? So last one serves the best. The reduced fixed cost, but there is some flexibility in the budget as well. Next, you are a cloud architect at a company that you has recently migrated its infrastructure to AWS. Your manager has asked you to debrief your team on which responsibilities the customer has when it comes to securing cloud resources. What is the customer responsibilities based on AWS shared responsibility model? So, one second, let me drink water. Basically, based on shared responsibility, as customer, what are your responsibility? Physical security, you are not taking care of logs, security guards, not this. Managing operating system patches, yes, depending. So yes. Networking and infrastructure hardware maintenance, you don't maintain like optic fibers and stuff, so no. Encrypting client-side data, yes, HTTPS, you can enforce encryption, right? Or allowing SSH. Updating compute storage, no. Storage software like those ones which are running on server, no. The servers itself, which are using by, let's say, firewalls and stuff, I believe. Yes. Okay. So we are good on that part. one thing I will tell you, always read through all the options during your assessment, because a lot of time when you read through all, you are able to like also remove the ones which are wrong, so you don't are not confused, and you can pick the best choice, where some of them have wordings which can confuse you and you can lose marks. A finance company is interested in migrating to cloud. They are curious if they will have enough staff to secure both their office space and the physical infrastructure of their cloud computing resources. What is the best described company's responsibility when it comes to securing physical infrastructure in cloud? Right? The company does not have any responsibility when it comes to security in cloud. Not true. There are security, but which type? AWS is responsible for securing physical infrastructure, and the company can focus on securing their data and application within the cloud. Yes, right. Company is fully responsible for securing all physical. No, including data center. Yeah, definitely no. Shares responsibility with the cloud provider for security physical. No, they don't. For physical infrastructure itself, they don't share responsibility. That's good. Let's go to the fourth one. You work for a sports apparel company that is expanding its operations to global customers. The company wants to deploy resources to multiple AWS locations to archive high availability or achieve high availability. You are tasked with explaining the basics AWS global infrastructure to the COO. The COO needs help understanding the difference between AWS regions and availability zones. Which statement best describe regions and availability zones? So remember, region is like Ohio, Delhi, Mumbai, Vancouver. Availability zones are lower than regions where there are multiple availability zones. And inside availability zones are the data centers. So AWS availability zone is a geographical location that contains two or more regions. No, region is bigger than zone. A region is a single data center, and an availability zone consists of multiple data centers. No, a region consists of multiple availability zones. Availability zone spans multiple physical locations across regions, and regions are located across the world. Kind of. A region is a geographical location that contains three or more availability zones. Yes. An availability zone is a distinct location within a region that contains one or more discrete data center. Yes, perfect. A large enterprise is looking for to lower operational cost. Remember OPEX and CAPEX? This is where it comes. They are hoping to reduce the operational overhead associated with managing their own physical infrastructure. So they do not want to maintain more land, power, electricity, security guards, secure engineers. Yeah, I told you, like, I will go in deep. I will make sure you guys pass. I'm going to be here. Reduce the operational overhead associated with managing their own physical infrastructure. What is the best describes which advantage of cloud this enterprise can benefit from? So they don't want operational, they hoping to reduce the operational overhead associated with managing their physical infrastructure. So they have CapEx already invested, but they want to lower the operational cost around it. So benefit of economy of scales, increased speed and agility, no. Benefit from massive, those are benefits, right? But not in this case. Benefit from massive economies of scale, no. Stop spending money running and maintaining data centers, yes. They don't have to spend money on operational stuff. Stop guessing, there was nothing mentioning about capacity, projection, blah, blah, blah. 6. Your company is planning to launch a new web application that will serve users across the world. To help ensure the application performs well and remains reliable, the IT team plans to use AWS for its vast global infrastructure. The two things that best describe AWS infrastructure related to this situation: application performs well, remains reliable. Performs well and reliable, these two. Ease of use, that's actually like application ease of use, that depends on you, nothing to do with cloud. Compliance with regulatory, there's nothing mentioned about like compliance and all those stuff. Cost saving, they don't care about the cost. What they care about, performs well and is reliable. Performs well and is reliable. You are a software developer working for a company that's planning to migrate its existing application to the cloud. Your team lead has asked you to explain the client server model to the rest of the team, how cloud computing fits into this model. So basically, you already have things in your prem, you want to have it on cloud, right? And now you are explaining what services AWS will be doing, what responsibilities AWS versus you. So the best describe this in client server model. The client is responsible for securing the data, and server is responsible for server basically AWS securing the physical hardware. Cloud computing replaces the client server model. It doesn't replace this. Cloud computing is the client server. Client server model is outdated. No. In client server model, the client sends requests to the server, which processes the request, sends back responses. Cloud computing provides scalable server resources that can be accessed over the internet. Yes. In the client server model, the server only handles data storage and client performs all processing. No. A government agency, this is important because this is something they will ask 100%. There will be at least 1 or 2 questions about it, because these are the things that like makes it hard for companies to have things in China. Remember this. A government agency wants to maintain complete control of its IT infrastructure but plans to use AWS cloud services for physical applications or specific application. What deployment type is best for it? Control over its IT infrastructure but want to have AWS cloud services for specific things. Why hybrid? Because physically they will be able to access everything around it, but because of AWS cloud services, they can use certain things like their AI and have it. Moreover, with hybrid, AWS provides certain specific hardware to help in these situations. And even that, moreover, above this, you will learn is AWS and every single big cloud have government specific location that you have to be a government specified or government verified and allowed vendor to use those data centers or availability zones. And government is like heavily monitoring those specific regions. If you get those, you get you GG's, man. Okay, module summary. I think that was great. We covered resources, what is cloud, share responsibility, and regions and stuff. Okay. Return to the outline. What is the cloud and compute and stuff? Yes, sir. W's in the chat. French. Okay, I think yeah. I will go to the bed. I think we can cover one every day. It's like not hard. Just how much hours it took? It just took 2 hours. This could be more. Hota hai. That happens, bro. Of course that happens. Compute, this is going to be fun. Launching your own AWS EC2 instance, pricing around it, scaling. And I will show you something that is very important for a person like you for going into startup. I will have that too. I'm actually like talking to someone to have this specific thing you are mentioning, teaching about this too. I'm talking to someone, I have emailed someone, and the guy is very good. So hopefully there will be something. Oh, but this was good. This was good. I'm actually like also planning to give my AWS CCP because I have Azure, but I think I can give one in the last week of May. I will give my exam too. I can't reveal that, brother. I can't reveal that. Come on. I can't reveal that. I don't know. I don't know. I don't know. I don't know. Guy is great though. The guy is great. That's all I will say. Okay, lads. Hopefully you guys had a good one, right? You guys enjoyed this. No, actually, that's what Vrench, you should ask. Like, hey, okay, you don't want to pay me during my internship, but if I learn something, I want you to pay for my certificates, and I want compensation in terms of like these XYZ things like stocks or something. Those are the things you can ask during your interviews and stuff. Like, hey, I don't want to work just for free. There should be something for me as well. They're like, oh, there is experience. I'm like, experience will be come from people that pay too. It's not like, but in your case, if I'm getting you experience, I'm building you something. I want something more, right? Always there is like great ways you can negotiate. Always find the extra angle. And you can also, this is something if I was in your case, right? If I'm working on startup and not a multinational organization, I'm working for a startup or going for an interview in a startup, I will tell them, hey, you know what? I will be a developer, but you have to pay for my this. Why it will benefit you? Because you can say on your website, we have AWS certified developers in our team. That's a big sales thing for them and for you. Yeah. Yeah, they don't care. Like, here's the thing about corporate. I have told my managers I'm great with security. I know about web security so much more than other people. I'm not getting chances, right? Yeah, it's all about selling. It is about selling. It's about selling yourself and buying, getting opportunity. So always I'm saying, make sure if you are going for the thing you were saying with the startup, ask them for a certificate. Tell them, hey, it will be great for you. You can put it on your website. We have AWS certified people. Sell yourself. That's what you will do for the rest of your life. Self appraisal, yearly self appraisal, biannual self appraisal, monthly self appraisal, blah 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 blah. Always selling. At this point, I stopped. I'm like, see what I'm doing. I don't think anyone is coming close to me in terms of learning. What do I have to sell? I got everything delivered on time. I stopped doing that. But because I used to sell so hard, now I have the confidence. I'm like, fire me. I banned to. Yeah. But I have worked my ass off for this. I had lost a lot of basically I lost a lot of friends. I lost a lot of people, but that was at the end because I was able to make sure my family is provided. It's all worth it. Remember at the end who you care about the most. If I actually like make money, I told you like I will love to support people more than before becoming a full-time streamer. I might actually just help people more. So yeah, let's 1:20 a.m. for me. Good time to go to sleep. Coming tomorrow, and we'll cover the TryHackMe one, right? And I have sent Hack the Box certain messages. I've sent couple of other guys messages. If I get some bulk vouchers, we might also I will say see if I can get some payment from them and just promote their stuff on the channel. Okay, so hopefully everybody can get benefited soon. Okay. Okay, but thank you so much all for joining. Hope you guys have a good one. And I will see you guys in the morning today for first learning about Linux privilege escalation from TryHackMe. Then we'll do a study with me stream. Okay, just remind me about that. Till then, thank you so much, lads. Bye, Wrench. Thank you, Rover. Thank you so much, Almivar, Unknown, everyone, Code Guy. Thank you so much, lads. And Yuan, thank you so much, boss. Panda, thank you. Have a good one. And here's the song made by hackers for hackers for you. Thank you so much. Peace.
In the wilds, we're the ghost. Ego's king, we rule the host. Masks on screens, we wear them proud. Silent hands inside the cloud. Flicker in the firewall glow. Name in red on a watch list row. Every trace that they think they own, we erase, turn it all to smoke. Hack the world, that's the dream. Pull the thread of the global seam. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the crack machine. Hack the world, the final scheme. the system, break the code. Watch the virus overload. Black hood up, eyes run cold. Turn the silver into mold. 10 fake memes on a single wire. One small spark, whole grid on fire. Who owns what when the locks all fail? Who holds power when we lift the veil? Heartbeat sync with the scroll. Cursor dancing on the soul. All their walls built tall and proud. We just walk straight through the crowd. Hack the world, that's the dream. Pull the thread on the global scene. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the cracked machine. Hack the world, the final scheme. Are you in or out tonight? Hey! Ride the edge or run from sight. When the curtain tears in two, will the ghost look back at you?